go to page 150 of your journal and get the definition for inverse functions. Copy that from the side. Then take a look at the horizontal line test. We can see here it's very similar to the vertical line test, except obviously we will be drawing horizontal lines instead of vertical lines. When the inverse is a function, it passes the horizontal line test. So any horizontal line that I draw will only go through the function once. If the inverse is not a function, that means we can draw a horizontal line where it passes through the function twice. So the inverse does not exist for that example. Now go to your packet, page 15, and we're going to start with example 3. We want to find the inverse of f of x equals x squared with a restricted domain of x is greater than or equal to 0, and then graph the function and its inverse. So I'll start by making f of x y, and then I'll switch the x's and the y's. So I have x equals y squared, and then we want to take the square root of both sides. So remember, plus or minus square root of x equals y. And that's going to be our inverse function. So we'll say plus or minus the square root of x is going to equal the inverse. We'll call it g of x. This plus or minus is restricted by the domain, so we only need the square root of x because it's for x is greater than or equal to 0. So we only need the positive part of this. So if we graph this, my f of x is just x squared, and my g of x is the square root of x. We can get rid of that negative. I'm going to plot just a few points that I know. So 0, 0, 1, 1. 1, 1 should be about here. And then we can plot 2, 4. Because 2 squared is 4. So this would be f of x. And my g of x, I can plot 0, 0, 1, 1, and 4, 2. And it will look something like that. This will be my g, this will be my f. Looking at example 4, we want to consider this function and see if it's going to have an inverse. To do that, you can just graph it in your calculator and just sketch a graph to see if it passes the horizontal line test. So if I graph 2x to the third plus 1 in my calculator, it looks something like this. And I can see clearly that's going to pass the horizontal line test. So yes, an inverse exists. So we want to find the inverse by making this y and switching x and y. So we have x equals 2y cubed plus 1. Subtract 1 from both sides, and we get x minus 1 equals 2y cubed. Divide both sides by 2, so I'm going to get x minus 1 over 2 equals y to the third power. And the last step will just be to raise both sides to the cube root. So we'll have the cube root of x minus 1 all over 2 is going to equal my inverse. We'll call it g of x, inverse function. And then we're done. Now take a look at example 5. We're going to do the same exact thing. So we want to sketch a graph of this function. And I have 2 square root x minus 3. So when I graph that, I see it starts here. And it just looks like a little line going to the right. So this clearly will pass the horizontal line test. And we can find the inverse. So make f of x y. and switch the x and y. So we have x equals 2 times the square root of y minus 3. Divide both sides by 2. Actually, square both sides first. So let's square both sides. And we'll get x squared equals 4 times y minus 3, because 2 squared is 4, and the square root cancels out with the exponent. So then I want to divide both sides by 4, and I'll get x squared over 4 equals y minus 3. And then I can add 3 over. So I get x squared over 4 plus 3 equals y. So my inverse function, I get g of x equals x squared over 4 plus 3. And that's my final answer. Now I want you to go to the next page, example 6. For example 6, we want to verify that the functions are inverses of each other, f and g. In order to do this, we have to calculate f of g of x. So f of g of x and g of f of x, and then simplify, and we should get x for both answers. If this is true, then they are inverses. If this is not true, then they are not. So to do the first one, I need to do f of my function g, which is x plus 1 over 3. So that means plug in or substitute in x plus 1 over 3 in place of the x in the f function. So I'm going to get 3 parentheses x plus 1 over 3 minus 1. These 3's will cancel out, and I'm left with x plus 1 minus 1. What does that equal? Yeah, it's just x. So that looks good. Now let's try the other way. We're going to do g of 3x minus 1. So that's going to be put g or 3x minus 1 in place of the x here. So I'm going to have 3x minus 1 plus 1 all divided by 3. This minus 1 and plus 1 will cancel out, and I'm left with 3x over 3. What does that simplify to? Yeah, just x. So this is what we want, so we can say, yes, they're inverses of each other.